between also, I hope that in case anyone has any questions, please do feel free to stop me in between. I would also sometime from time to time like to ask questions to keep things more interactive. So I hope that's all right.
Yes, yes, please.
Okay, so how 3D printing is disrupting the medical and dental industry. I'd like to start with putting forward a bit of a case, actually. Since all of you are doctors here, I'm sure reading this particular case, you'll be able to make a rough picture in your mind of how this patient's anatomy would actually appear if you were to not see the patient first and just see this description. Me coming from a non-medical background, this does not make a lot of sense to me, but I'm sure even for you, you might not be able to get a complete 3D picture. You're getting a very rough picture. Now, just these words cannot give an accurate representation of what the patient must be going through, what the patient condition would be, right? How this can be improved is, for example, if we had an X-ray of the patient to see maybe where the particular fracture was, what teeth are misaligned, if there is multiple fractures or a single fracture. An X-ray gives us a better representation of that. Moving a step further, if we had maybe a 3D illustration, that would get us an even better representation of what the actual patient case is. So if you are going to operate on this patient and you have now this illustration, you have a better idea of what to expect when you open up the patient or what particular approach to use in your surgery. And if we go a step ahead of that also, and if we have a complete 3D model of this patient, this gives us the perfect idea, the most you can say patient matched idea of what to expect in surgery. So, I mean, the point I'm trying to paint here is the fact that over time, our visualization of anatomy has evolved greatly. In the olden ages, they only had some medical illustrations. Then X-ray technology came about. Then CT scans came about. Then we had MRI scans even, so that soft tissues could be visualized. On these CT and MRI scanners, then they developed 3D rendering capabilities, which would allow the doctors to get some sort of a 3D visualization within the CT or MRI machine. And now it is in fact possible to get those 3D models in your hands as physical replicas of the patient anatomy. So I'm sure all of you or most of you must be familiar with this evolution of the technology when it comes to medical visualization. Any questions so far?
No, I don't think so.
So how has all this been possible? It's been possible through medical 3D modeling and 3D printing. This is the process whereby now CT MRIs are fairly common when it comes to any surgical procedure. Those CT and MRI machines are put into a software that helps to create an accurate digital 3D model. And then that 3D model can be converted into a physical 3D model using the process of 3D printing. So what is 3D printing exactly? 3D printing is a process which enables the creation of physical objects from a digital 3D file. How it does this, it deposits material layer by layer to create a final 3D part. The key component here, though, is also the fact that the input that goes into a 3D printer is a digital file and not just a man-made drawing. So by digitizing the whole process, it ensures high accuracy. Why 3D printing has become such a big phenomenon or is catching on so quickly is there's a number of advantages that 3D printing offers. Number one, the biggest one that is there is the customization aspect. Because of compared to other manufacturing techniques such as this traditional CNC machining or injection molding, you have a lot of support components required. You have a big mold that you need to create. You have to cut out a lot of material. So there's always limitations of the kind of mold structure you can create or in what angles and directions you can cut out material. That limitation does not exist with 3D printing. which is why it allows us to customize the shape completely to our requirements, and it enables us to create extremely complex shapes. So we have all the freedom of design to create as complicated shapes as we want. Another important factor of why 3D printing is so useful is the fact that it allows you to manufacture parts on demand. With traditional manufacturing techniques, you need to give large orders, you need to produce in bulk to ensure that it is cost efficient for you. That is not the case with 3D printing. You can print a single part, you can print 100 parts, the costing will be roughly the same. So it allows that on demand manufacturing because of that digitization of the entire workflow, as I mentioned. Apart from that, of course, the fact that you're adding material layer by layer, you're using only as much material is required. You're not starting with a big chunk of material and then removing unrequired material, such as in subtractive manufacturing techniques. So that's why with 3D printing, you get to save a lot of time and material when creating parts. When we look, why has this become so useful in healthcare? What are the applications of this in healthcare for 3D printing specifically? They can largely be categorized into four different applications. We have anatomical models, we have patient specific instruments, we have customized implants, and we have orthotics and prosthetics. When it comes to anatomical models, these are basically the exact replicas of patient anatomy, which are constructed from the patient's CT or MRI scan. So, as I showed in my first example there, where you can either just read in words what the patient has been through, or you can actually see an exact copy of his anatomy in your hands. And how 3D printing helps in this is because anatomy is irregular. Anatomy does not have any regular shape, um, which is why it is very difficult to produce anatomical models using traditional manufacturing techniques. With the capability of 3D printing to produce customization and enable you with design freedom, you get to create anatomical models which are 99% replica of the exact human anatomy. With this model now, you can visualize what to expect in the operation theater before you go in. You can in fact even simulate the surgery on your model, so that way you are better prepared when you go into the OT. It also helps with any kind of instrumentation, plate pre-bending, any kind of instrumentation preparation before you go into the OT, because what you have here is the exact replica of the final anatomy. Um, Another very key application when it comes to anatomical models is it also helps with the communication amongst the clinical team. So in any surgery, you have a number of clinicians involved. If all of them, if any two clinicians also read a CT scan, sometimes their visualization of that CT scan might not be the same. What this anatomical model does is brings the entire clinical team on the same page. So to ensure that there's no miscommunication in the OT, everyone is well communicated and has a clear understanding of what to expect. What this model does also help with is communicating with the patient. Um, I'm not a doctor myself, but I've seen cases and I've experienced cases myself also where the doctors have a hard time explaining to the patient what's going on with them. I'm sure all of you must have also faced this challenge. So such a model helps the doctors explain to the patient exactly what's wrong and what needs to be done, and that way you can convince the patient more easily for the surgery or for any surgical approach. Lastly, and I think a very important component that is now slowly becoming more important is the educational perspective of anatomical models when it comes to students and residents. I think so far most educational work was done using cadavers or images in textbooks. But with the advent of 3D printing and anatomical models, the students don't need to rely just on cadavers and images. They can actually print the models out themselves and then have a better understanding of the anatomy, which improves their learning perspective. So these are the different ways in which anatomical models, 3D printed anatomical models, are helping improve the medical field.
Yeah, there is a question open. Which specialty do you think is using the 3D models Max, which medical specialty?
It's definitely oral and maxillofacial.
Okay.
Was that question from you, ma'am?
Yes.
So it's definitely oral and maxillofacial, and I think there's a number of strong reasons for it. Number one is it involves the face, it involves facial aesthetics, and that's where I think both patients and doctors do want to achieve the best possible outcome, not only functionally but aesthetically also. So which is where having this 3D visualization helps improve or get a better output, get the best possible output.
Yeah. Thank
Yep.
you.
This was a case study, actually. I mean, I just thought I'd show even a case study, which was done at Max Hospital in Saket, New Delhi, which involved an orbital fracture. So, in this case, what the doctor did was he created an anatomical model whereby the healthy side was mirrored on the unhealthy side. And what he could use that for is to pre bend his plate before going into the surgery rather than doing that bending intra op. What that helped him achieve is a much better fit. It reduced a lot of the OT time, and of course, that led to better patient recovery also. So these are different ways in which it's not only just to visualize, but even to prepare your instruments beforehand to give you a better output, a better surgical output. Yep. Any questions?
Mm. Any questions from the participants? No, I don't think so.
All right. Just want to stress upon the fact again of how this is helping with the educational perspective, whereby we have a number of institutes even now looking at creating these digital anatomical libraries or even physical anatomical libraries, uh, which can be used very well to teach students the different anatomies, not only at the basic level, but even at the specialized level when it comes to more complex cancers, complex fractures, complex anomalies in the body. Such cases could be preserved and used to teach specialization students. Not only that, they could even be used for the product development work in case there are certain newer products that need to be developed based on these specialized cases. Such anatomical models help with that perspective also. Coming to the next application, patient-specific instruments. Now, in this case, the anatomical model only helps with the visualization. But what if you have a particular surgical approach in mind and you want to translate that from the practice table to the OT table? How do you do that? So this is where patient-specific instruments come into play. When it comes to sawing or drilling a certain part of the body, the angle in which it is done, the length at which it is done, the position in which it is done becomes very important. How do you control that? Of course, the surgeons or the clinicians' skill. This is where it comes into play. However, how can we try to reduce the error involved? Is by pre-planning the surgical approach on software, creating a customized device, a patient-specific device that helps guide the clinician in the operation theater while doing his cut or his drilling. What this helps the clinician achieve is a much higher increased accuracy. It does definitely reduce the risk of complication for very fine cases. For example, where the margin for error is maybe less than a millimeter or less than 2 millimeters, to ensure that the cut does not go a little wide of the intended region. Using such a surgical guide will help ensure that the cut is placed in the perfect angle and direction. Um, this also does help reduce the OT time, which also leads to reduced recovery time for the patient. So overall, patient-specific instruments do help achieve a much improved surgical outcome. Um, Multiple applications for this have already been seen. Most of all, of course, has been again oral and maxillofacial. Apart from that, orthopedics and oncology is also a major sector whereby is a major specialization whereby these patient-specific instruments play an important role. This is because, again, for example, in orthopedic oncology, the angle of cut, the orientation of the bone joining does play an important role in the recovery of the patient. So to ensure you get the perfect direction of the cut and the perfect, you don't it doesn't lead to any disjointed bones. This helps ensure that. So this was again a case that was done in Max Hospital, Vaishali in New Delhi for a mandible reconstruction case. A mandible reconstruction case using fibula. Now, in this case, it becomes even more complicated because the angulation of how the fibula needs to be placed between the two components of the mandible is very important for a good recovery and good both aesthetic and functional output of the patient. Because there's two separate components involved here, the mandible and the fibula, to match the orientation is very important, which sometimes is difficult to do in the operation theater. So if the doctors have the capability to visualize this beforehand and plan the surgery on software, plan their exact cuts, and then reverse engineer those cuts into instruments, as you can see here, which have cutting planes already pre-designed into them. This helps ensure that the cut is perfect and the surgical output is also as intended. So this is how patient-specific instruments are used in surgery. Any questions?
There's some in the chat box
Okay.
asking me about my experience on pre-bending of plates. So pre-bending of plates is really useful if you can mirror the normal side onto the damaged side and then you pre-bend, then that is very accurate, and you just have to place it intraoperatively and it will be like Arpan showed a case of orbital blowout fracture. Yeah, this one. So in this scenario, if you just try to in a fractured position only, if you try to bend, then it becomes difficult. But if the mirroring of the normal side is done, so this side also, it's just like the normal side, and you adapt your plate here, then it is very, very useful. It is good for most of the orbital floors. We do it for many sometimes for mandibular fractures, but then we are also into designing our own plates, and so sometimes we do design our plates and then get them in metal. So often, many times we use those. But yes, if you don't have the opportunity to have your own plates and prosthesis, then it's always good to just have the mirrored to normalcy, and that 3D model you can adapt your plates on and use the stock plates which are readily available, just adapt them pre-operatively, use them. Yeah, over to you, Arpan.
Just to add, it's a much more even cost efficient way though, because of course I'm going to come to that in the next section, the customized implants,
Yeah,
which do tend to become a little expensive.
yeah,
This is a little more cost efficient way of having a customized approach using a generic implant.
yeah.
All right. So yeah, after the patient-specific instruments, which involve both drills and cutting guides, let's move to customized implants. I'm sure a lot of the people have already heard this phrase before multiple times, but it's basically a case whereby your generic implants, because the anatomy is so irregular and every patient body is different, one generic implant might not fit every particular case. So in such a case, it does become important to get an implant that is designed specifically to the patient's missing anatomy, which is known as a customized implant. This fits the defect region perfectly and helps restore both functional and aesthetic properties. So the advantages here are pretty obvious, that it does help the patient and the doctor achieve a better fit, function, and aesthetic replacement. In fact, even the smaller parts, smaller details such as maybe screw hole angulation can be designed into the implant so that we are making sure we're not touching maybe any important blood vessels, or maybe we're trying to screw it onto the hardest part of the bone. All that can also be integrated into the implant design. What this does do is also ensures that the implant failure risk is quite low compared to a generic implant, whereby sometimes you have to remove extra bone or place screws in non-ideal positions because the shape of the implant does not allow for anything else. So the fact that here you can customize everything to your needs ensures that the implant achieves a better fit, a stronger fit. This also does help with reduced OT time, because the fact is that this implant has been made exactly to the surgeon's requirements. The surgeon knows from where he wants to approach the surgery, where he wants to place his cuts, and what should be his entry route to place the implant. And by customizing all of those aspects, ensures that OT time is reduced. And so overall, we achieve much better patient care compared to using generic implants. What's also possible though now is the fact that a lot of these companies are integrating porous structures into the implants, so that they want to promote more bone growth and ensure better resorption of the implant in the body. So all these innovations are happening with customized implants in healthcare. One of the most common fields where this is being used is in neurosurgery and cranioplasty, whereby so far they would either use titanium meshes or they would use a PMMA plate. But because of a few of the challenges with that, such as increased risk of infection, non-ideal fit, now more and more neurosurgeons are turning towards customized implants to get the best possible fit and reduced rejection rate. And again, they're implementing porosity into the implant to promote bone growth through the implant so that it is fully resorbed into the body. Right? Any questions?
No, I don't see any question here.
All right. Lastly, coming to orthotics and prosthetics, this is, I think, a field which hasn't been given as much focus yet, but it's something that is definitely evolving very fast now. Um, uh, Basically, orthotics and prosthetics are the devices that are meant to substitute the missing anatomical components or support in the recovery of certain fractures and deformities. Now, with these components, though, customization becomes even more important, because especially when it comes to the recovery of a damaged body part, you want to ensure, maybe for example, bone healing is taking place in the correct in the correct direction, in the correct orientation. And if you have a cast which is generic or which is made using a complex process that has a much larger room for error, your room for the recovery also becomes very small. So in such a case, having a customized device that is made exactly according to your needs using some 3D scanning techniques, as well as such a device does give a lot more comfort than, say, the generic devices that were used before, like a complete solid cast. I'm sure people who have been through that would know even how itchy it gets, how hot it gets, how uncomfortable it gets. So the fact that now we are able to create orthotics with such new innovative designs help improve the comfort of the patients while achieving the intended functional output. What this also helps with, though, where 3D printing is really helping with this, is reducing the time to manufacture. I think in the past, the manufacturing technique for these kinds of devices was incredibly long, because you first had to take a wax pattern of the hand, and then you have to pour your mold into your plaster of Paris mold, and all of that. It was a very cumbersome, long process. With 3D printing, none of that is required. All they do is take an outward 3D scan of the hand and do their design on top of that digital file, and then 3D print it, and it's ready to wear for the patient. So this definitely reduces the time to manufacture. In fact, the entire digitization of the workflow is also enabling this technology to reach many different parts of the world, many remote parts also. Such as there was a case that was done in India, the Jaipur Foot Project, whereby even in the rural villages that did not have access to all of this technology, all they need is a phone scanner and a 3D printer. So through the phone, they're able to scan the hand, send that scanned file to maybe a central facility in Mumbai to do the design. That design file is then sent back to the rural area where the 3D printer prints out this kind of a cast. So the 3D printing and digitization is also helping this technology reach even rural areas, because that's a major problem in India, whereby most hospitals are concentrated in the cities and the rural area does not have access to the best of healthcare. This technology is helping to enable that. Any questions?
Mm-hmm.
So moving on, how else has 3D printing been? This is of course those specific application, but how is it on a larger scale helping the hospitals? Is it is now slowly getting adopted at the point of care at the hospital itself. So far, 3D printing was more of an outsourced service that was given to individual companies to do the 3D print for them. But now more and more hospitals are seeing the benefit of adopting this in-house. What this does is by having a centralized 3D printing facility along with the radiology department, because the input to 3D printing comes from imaging. So it always makes sense to integrate it with radiology. This enables a much faster turnaround for whenever the clinicians require anything 3D printed. This also does help for any of the trainees or the residents to get access to this technology whenever and wherever, in however way they require. A number of institutes, such as KGMU for that matter, have been doing a number of workshops using these models. So, where in the past they'd have to depend on maybe an outsourced company to provide them with these models, now that isn't required. Whenever they want to do a workshop, they have the flexibility to just print the models in house and use it straight away in their workshop and simulation labs. So what all this does is definitely helps improve the patient care, first of all, and then secondly helps improve the quality of the medical care also, because you have now students that are better trained, that have a better idea, that have a better understanding of the complex anatomies. So this is how 3D printing at the point of care is definitely helping revolutionize the overall medical field in a large way.
Arpan, have you also come across any one like from dentists?
Uh-huh.
Any dentist asking you for some 3D printed models of some sorts? So how
Then
much in dentistry it is in use?
yes,
Like
so in dentistry, actually, more than the models, even way it's being used as is, for example, in the creation of the braces or aligners.
yeah,
That seems to be the biggest application in dentistry, whereby in the past that process of creating the clear aligners was a rather complex process, whereby you had to create them using a certain complicated waxing technique and all of that. Now, none of that happens. Now all the 3D different in the aligners, the different models are created using 3D printing, and all those models at once, the aligner can be created on them using the aligner material. So that's really helping to drastically increase the output and the work rate of these dentistry clinics, which are also providing aligners.
yeah. As per means what I would want to say here, that just printing all the models is of no use. Means whatever patients come to us and we if we start printing for each patient, it's not required actually.
Mhm.
Many of the times it's better to do virtual surgeries or virtual planning and just print the guides. That's what we are using at present. So all the guides are 3D printed. So
Mhm.
whatever we have to use intraoperatively, we have those jigs. Uh, Rest of the skull and we don't 3D print for most of the cases. We
Right.
basically use, yeah. Otherwise, there's so much of plastic material accumulating in your lab,
Right.
then getting rid of that much of plastic is again a problem.
Yep, I think that's very well put, ma'am. The fact is that it does differ greatly by the specialization also. So depending on the specialization, the application might be different. For example, in oral and maxillofacial, as ma'am mentioned, it doesn't all. I mean, printing a 3D model is not always required. It does better help to do the surgical planning virtually and then just print the guide. But for example, in a field like cardiology, especially pediatric cardiology, printing a 3D model out definitely helps the cardiologist and the cardiac surgeon to better plan their surgical approach. Or to maybe see if they don't want to maybe do a surgery just by looking at the anatomical model. That model helps them decide that also. So the application does vary a lot by specialization.
Yeah. We in our lab, you would be surprised to know, the organ transplant team was using our lab facilities for liver transplant cases.
Mhm.
So they used to get the liver cutting guides. So wherever they need to cut, so
Wow.
the vessels they used to segment, and then few of them means initially we did print the vascular part, the guides, and the complete liver in 2 and 3 segments, so that they can keep the vascular part inside the liver and just to use it as a study model. But for the, I think for 24 cases, we did use liver cutting guides. So there were guides which were used intraoperatively, just basis on the virtual surgical planning for areas where the cut had to be made. So in what direction, so as to save the vessels. Yeah.
Amazing.
Yeah.
So I mean, I'm sure ma'am is I think a very good example here of how having that 3D printing in-house has helped enable all this innovation, because the fact is that when it's not in-house, this thought might not even come of even using 3D printing in a liver replacement surgery.
Yeah.
It's only because the fact that this technology is just available right there at your doorstep does
Mhm.
enable a lot of innovative thoughts in this
Mhm.
direction.
Yeah.
So that's how.
We are also doing some breast models,
Mhm.
study models. So just scanning the part and creating study models.
Right.
Yeah. So the lab is not only looking at maxillofacial, but
Yeah.
various other specialities are using, because as you rightly said, because it is in-house. Orthopedics also, they also want for some bone tumors, they wanted our help, that
Right.
please, if you can prepare the guides for us, so we know exactly where to make our cuts, so
Right.
that, yeah, that's,
Yeah.
it's good thing. Yeah.
Yeah, definitely. And that's why I mentioned though, even like generally what we have seen, the trend in the West, for example, because 3D printing does not only apply to one specialization, it caters to many different specializations. It's normally housed under the radiology department, because again, that's radiology is also a department that caters to many different applications. So that seems to be the ideal fit. But here, I think Dr. Divya has been generous enough to share her lab with the other departments, so that is not a problem with KGM.
Yeah, we wanted to make use the best. So if
Yeah,
the lab is so expensive to set up, so once it is there, it should be used by various specialities. So
correct.
there is someone asking me,
Uh-huh.
what is the, how long does it take to print a jig for an orthodontic surgical case? Oh, jigs is not very time consuming. The entire skull takes long. So if you need to print a skull, it would take, depending on the what type of printer you are using, maybe from 2 days to 3 days. But jig is usually 1 hour,
Yeah,
one
a
and a half
couple of
hours.
hours,
So
1 to 2 hours,
yeah,
should not take more than that.
depending on what the size, what you are wanting. So these are comfortable printing. Don't take much time. Yeah.
All right. So shall we move on? Any more questions? So looking at now where the innovation is happening with regards to these applications of 3D printing, there's a few different sectors which seem to be the key innovators here. One of the biggest sectors is materials. Now, so far, when it comes to anatomical models, they're made basically in plastic, while surgical guides are made in a more what do you say, a biocompatible material, because they require contact with the patient. And implants have been predominantly been made in titanium. However, there are innovations that are happening across the sector to improve, to maybe use more materials depending on the different applications. So, for example, when it comes to the implantation for hard tissues replacement, there's a lot of innovation that's happening in the material of PEEK as well as other high performance polymers, mainly in the specialization of CMF and a little bit of orthopedics also. You might be already aware that, for example, in spinal cases, PEEK is already used in certain spinal cages for the replacement of lumbar discs. Um, that is being innovated upon further to integrate porous structures within PEEK also, which is something that has not been possible so far. So in this way, more materials are being brought about for different applications. There are also bioresorbable materials that are being brought about for orthopedics. These are the ones that would be resolved into your body, and that's why they're made out of a bio-related material. In cardiology, for example, also you have some soft tissue materials that are being innovated upon, so that they can be used, for example, in the replacement of heart valves. And lastly, there is of course bioprinting is a major aspect which we have a long way to go for still, but it's not stopping people from, of course, leading that front. So this is whereby they're looking to print live tissues that can actually be then implanted into the body. So these are the different areas whereby materials are being innovated upon to improve healthcare.
Yeah, Open, there is a question on
Yeah.
PEC. I don't think PEC is available in India as yet. PEEK is there, but PEC, I don't think it's available. Any idea if it's
Uh,
available in India?
so PEC is available. The medical grade PEC is not yet available.
Yeah,
That is the challenge.
yeah.
PEC is because it's also been. I mean, PEC also has some applications in industrial sector.
Okay.
So as a material, it's available. Its medical grade is not yet available.
Okay. Anything to talk about on smart implants?
Smart implants means the sort that change with time or something like.
Like they gather information. So once the implant is there, the customized implant is there. It has
Uh-huh.
some sensors and it collects information. Uh,
Um, I mean, I've honestly,
yeah.
in my experience, I've not
Yeah,
come
the
across
how the
it yet.
healing is taking place in that area, releases antibiotics sometimes. So if there is something, the pH is changed, so
Okay.
taking the gathering information from that, it may release antibiotic. So that is also in research phase.
I mean
So
that
smart implants.
that must be, it's not something that I have come across yet, but it definitely does sound like a very high potential application, because that could definitely also help revolutionize the post-operative care
Yes.
significantly.
Yeah.
That does sound like a great idea. In case anyone's interested, I'd love to work with them on that.
Yeah.
Right. So that's what's happening on the material side of things. Apart from that, there's lots of innovation that's happening on the software also. Because at the end of the day, when it comes from the CT to go to 3D modeling and 3D printing, software plays a very important role to enable all of that. And that's why there's a lot of most of the innovation that's happening on the software side is, one, to create automated tools to help speed up this process and just make it a lot easier, even for people who are starting off as novices in this field. Um, Also to ensure that the model that is created is of the highest quality, is of the highest accuracy. There's lots of AI and machine learning that's going into the software, so that the software can keep learning itself, what is good and what is not good, what is a good model, what is a bad model.
Mm-hmm.
There's lots of integration that's happening with the legacy systems, with the CT and MRI systems and PAC systems, to ensure that the institutes can have this deployed, this kind of technology deployed throughout the institute, and maybe not just in a single department, maybe not just in a single computer. This would also in turn help with more of the regulatory aspect of ensuring that this is used in a more regularized way. And lastly, there's lots of course, design tools that are being added to ensure that the process of designing guides, of designing implants, of designing any kinds of devices is just very easy for not only for engineers, but even for the doctors themselves. So in this way, software plays a very important role, and that's why lots of focus is happening to improve the quality of the software.
Yes. Any
Uh,
questions? Are there any questions? Yes, Roshan Chandra is asking about magnesium and zinc based implants.
okay.
So, yes.
So
Uh,
with magnesium, though, there's still it's still a rather long way to go, because of the fact that it's highly oxidized. It gets oxidized very quickly, and to keep it stable is the challenge.
we are doing an animal study on magnesium and zinc based implant. Let's see what comes the result.
We're all looking forward to the results. Right?
Yeah. Let's see.
Any more questions?
No.
Lastly, an important component is also the visualization itself. So I think, as ma'am mentioned before, also not every part needs to be 3D printed. In a lot of the applications, just 3D visualization of the part, of the model, or of the surgical approach can also help. In such a case, augmented reality and virtual reality plays a very important role. So this is helping enable this kind of 3D visualization in a very immersive way. In this case, for example, you can have planning sessions between 2 or 3 clinicians, maybe each one even sitting in their own room and just put on a headset and they're both seeing the exact same model. So this will definitely help in the ease of communication and of surgical planning. It can also become a very good way to teach students or even educate patients. Same way, by getting a very good visualization, very immersive visualization of the anatomy, this will help definitely improve the experience of both the students to learn and the patient to just be more confident of the surgical approach that's being taken.
Are there any such centers in India?
Who are using AR VR?
Yes.
Yeah, there are already individual hospitals that are testing with them.
Okay.
It's not yet been done in an institute-wide thing, but yeah, there are individual doctors and individual hospitals that are already using AR VR for some initial work.
Yeah. And what about the Google Glass?
That's not something that I have heard
Uh,
of yet. I think the
okay.
technology that's leading this right now is, for example, Microsoft is using its HoloLens
Yeah.
extensively for medical applications, and
Mm.
apart from that, there are a few Japanese companies that
Okay.
are doing some work in this field. So those are the ones that I've tested on personally.
Okay.
Yep.
We are into purchasing.
Okay.
We are, yes. Let's see when it arrives in our lab.
That would definitely be a great addition. I mean, these are all again those additions to a 3D printing lab
Mm.
that would definitely help in your overall output from the lab.
Yeah.
Yeah. I do know Amrita Institute in Kochi already has I think adopted this in their 3D printing lab.
Okay.
Yep. So in case you'd like to speak to them, you could.
Yeah. Yeah.
So yeah, so that's about it. I think that was basically my presentation on how this 3D printing is currently how it is currently disrupting healthcare and how it stands to disrupt it further in the future. So I'd love to take any questions right now if you might have any.
Uh, I don't see any questions in the chat box. So, Richa, would you like to speak on something just to add on to dentistry?
Uh, yes, ma'am. 3D printing in dentistry, if I talk of different specialities, has been mainly used for, easing out our ways. Like when we use in endodontics as surgical guides, so they have been discussed. They are being discussed time and again in most of the 3D sessions. But then there are endodontic guides where 3D printing is useful. Then, as for my specialty, I submitted a project in MAMS in this DHR lab for designing of templates, where restorations can be placed on teeth. So those templates can be 3D printed. Then there are 3D designing can also help in making of appliances, orthodontic appliances. Can that entire designing part can be done over the 3D softwares and can be printed in suitable materials. Now, the challenge is again the choice of the material which can be used there. So
Yeah.
there are a number of avenues still, waiting for exploration in dentistry, where 3D printing can be used.
Thank you, Richa. So, any questions from the participants? Um, okay. So, if not, then we can just take a feedback of the week one or the module one, because we abruptly ended the module one and we have no feedback of did it serve its purpose? Did you get to know something in a better way on scanning? Because that was mainly on scanning. Did you see different things, or could had it had been better? What are your suggestions? What do you expect in this week? Just to listen from you all.
Uh, Ma'am, sorry if I may interrupt. There was just one more question here
Yes,
from
please,
Roshan
please.
Chandra on what is the major 3D printing technique used in medicine.
Okay, go
Yeah,
ahead.
so I mean, if I could just answer
Yes,
that,
please. Yes, please.
it completely depends on the application here. The fact is that so far the application that is most common is the printing of anatomical models, and in that particular application, the most common technique is the FDM-based technology, because of just how cheap it is and how easy it is to use. Uh, when it comes to surgical guides, the SLA or SLS technology becomes more common because of the biocompatibility and the accuracy and speed required. And when it comes to customized implants, then you have your DMLS and your metal 3D printing techniques that become the major 3D printing technologies used. So it completely depends on application.
Yeah, tomorrow maybe we'll be talking on 3D printing printers available. So maybe that will help you in your query. Yeah. So anybody wants to share your comments? I'm sorry to bother, but we are yet to receive a link to day 3. The link is same for all the days.
Ma'am,
This week,
the recordings, I think
the recordings.
last session.
Yes, yes, for the Wednesday and Thursday, day 3 and day 4 sessions.
If I remember correctly, I have shared the link on your emails. The entire week is in one playlist, and I have shared the link. I'll again put it on the WhatsApp group as well.
Thank you so much, ma'am. I'll go back and check. I'm sorry if I haven't seen it. I'll check
Yeah,
it. I'll check.
yeah. So I've put it in one playlist, and the entire week is there. Yeah. So today's also we'll put the link and share with you. Ma'am, for very new technologies, if a short video can be shared, it will be much interesting and easier to grasp. Yeah, we'll try to put some video links.
If I could just, I mean, small
Yes,
piece of
please.
advice here is when it comes to new technologies and all of this, there is an amazing amount of content available all over YouTube.
Yeah.
All you need to do is just go search. So, I mean, the fact that even with all of this, when I joined this field, I came from a completely non-medical background. So even to learn about what is 3D printing, how is it used in medical, all of that is something that YouTube has been the biggest teacher for me. So I just advise that if you'd love to check out some short videos, just go to YouTube, type the word, and you'll be presented with a number of videos.
Yeah. Okay. So with this, if anybody wants to say something, speak up for the module 1. Otherwise, what you expect in the module 2. Otherwise, we'll then end the session. Thank you, Arpan. It was good to have you back.
Thank you, ma'am, for having me.
Yeah. So at present, your company, I suppose, is in peak printing, no?
Yes, the company that I work for currently has developed a peak 3D printing technology specifically for medical applications. So far, peak 3D printing was difficult to do in medical, and that's where my current company has innovated on to create their own in-house technology and enable that. So we sell peak 3D printers for medical applications.
Good.
Yeah.
Okay, so if nobody else is speaking up, we should end. Thank you.
Thank
you,
you,
everyone.
everyone.
Yeah. Thank you. Bye.